Okay, awesome. All right, well, thank you for coming to I had to count it. This is the 15th annual Seatech Symposium, and hosted here at Scripps. And Seatech is a program where we work together, the Scripps Whale Acoustics Laboratory and now colleagues from NOAA work together with our friends at the Mount Edgecombe High School on basically to do science together. We work together. We do research in various places around the world on learning about the ocean through listening. And we formulate this group of undergraduates and graduate students and postdocs and high school students to basically just to learn about the ocean together. So Seatech started, gosh, this is 20 years ago as an NSF iTest program, so innovative technology experiences for students and teachers. We started it in collaboration with the Ocean Institute in Dana Point, under the direction of then director of the Ocean Institute, Harry Helling, who is now the director of the Birch Aquarium, and his vision is still here in the Seatech program and up at the aquarium. So we carried on the Seatech program, working with Michael Mahoney at the Mount Edgecombe High School. And so every year we work together with students from Mount Edgecombe. Over the course of the year, they conduct research on underwater sounds and marine mammals, and then they come here to present the work to us. So I'm going to get out of the way, and I'm going to pass this to my colleague Ann Simonis, who's the co-director of the program, to tell you a little bit more.
Hi, everyone. Thank you so much for joining us, both in person in San Diego and online in Zoom. I am joining this year from San Francisco. A few weeks ago, I injured my knee and needed to have surgery and was not able to join the crew in San Diego, which was, to put it mildly, a profound disappointment for me. Working with these students is the highlight of my work, and spending time with them in person for this event is always so much fun. But even though I get to miss out on the fun this year, I know that our mentor team has it covered. You know, we have designed this program to work as a team, and so we recruit mentors to work with the students. The mentors are coming from various points in their scientific career. Some are undergraduate students, some are graduate students, some are faculty or staff researchers, and so yeah, I just want to take a minute now to thank all of our mentors at the very beginning for taking time out of your careers, your day, to work with these students and to join our mission to really redefine what a research group looks like. And for the students, because I have you all in front of me right now, I just want to say one more time that the work that we started together over the last semester or over the last couple of years for some of you doesn't stop today at the Research Symposium. You know, we will continue to work together if you want to over the years to come. You have learned some really exceptional skills analyzing underwater acoustic data that very few people in the world have. And these skills can translate into degrees and jobs. And I assure you that the folks at NOAA and UCSD and Scripps and now San Francisco State University, where I'm affiliated, want to give you jobs, paid jobs, to keep using these skills. So let's keep in touch and know that we always have your back. Okay, now I want to turn this over to my good friend and their teacher, Mr. Mahoney, so he can introduce the students and let them get started. So thank you, everyone.
All right, thank you, Anne. My name is Michael Mahoney. I've been a science teacher at Mount Edgecombe High School for 26 years now, 15 of which I've gotten to share with the Whale Acoustics Lab at Scripps, which is pretty awesome. So we are a state-funded public boarding school. And so we have about 400 students that travel from over 100 different locations around the state of Alaska to attend school with us for 9.5 months. So imagine your 14-year-old self getting on an airplane, flying maybe up to 1,500 miles to go to high school with a bunch of people you don't know. So I think our crew here of 10 students travel collectively over 5,000 miles just to come to school with us. Of course, Virginia being the least, and she lives in Sitka. So we are in the science department really focused on trying to do hands-on and real life experience science. And this was an amazing opportunity for us. So thank you very much to the Whale Acoustics Lab and the folks at NOAA for sharing their data with us, and their networking and their relationship with us is just, it's fantastic. So no one came here to listen to me. We wanna talk to the students. So we'll bring them up to introduce themselves.
Hello, I am Keisha Asko. I am a second year Seatech intern and I'm a graduate from Mount Edgecombe High School. Here's some photos of where I'm from, located in Alaska right there on the red dot, and then an aerial photo of New Haven. And then here's some photos of me at Edgecombe and some photos of me outside. And here's some other photos. And then here's some photos of my dog, Rocky. Yeah. And I came back to Seatech because I really enjoyed last year and the research, and also because it's gonna be my chosen field of study, like marine biology.
Hi, I'm Audrey Benke, and I'm a first year intern for Seatech. I'm from Nome, Alaska, and it's way up there. And that's an aerial photo. It has a population of around 4,000. And this photo is the Northern Lights outside my house. This is me over the summer commercial crabbing with my family, and this is me wrestling over the school year.
Hi, I'm Sarah Benke. I'm from Nome, Alaska. That's where it is on a map, and that's an aerial view of it. That's a picture of my family right there, and that's a picture of me during commercial crabbing season last summer. And I decided to take Seatech so I could explore the different types of research that are possible in marine science.
My name is Chelsea Blogger. I'm a 3-year graduate from Mount Edgecombe High School. I'm also from Nome, Alaska. It is on the map. That is a picture that I took this winter break on top of Newton. There's a picture of Nome. And there's a picture of me welding this year. And a picture of me at Torture Falls. The reason why I took Seatech is because my brother Orland took it, and we shared like the same common interests. So when he told me all the fun stuff about it, I decided to take it. And I'm currently deciding if I want to go into college for marine biology or architecture, or going to a trade school for welding.
Hello, my name is Harley Huntington, and I am a graduate from Mount Edgecombe High School. I am originally from Shishmarok, Alaska, right here, but I currently live in Sitka, Alaska, and I took Seatech because 2 of my brothers took it in the past, and I wanted to take it as well because they recommended that I take it. And right here is a cool picture of me in a silhouette shot because one of my hobbies is bodybuilding. And this right here is an NYO event. NYO is Native Youth Olympics. And this event is called 2-foot high kick. And I believe that this picture was 72 inches. It might have been 76, but I don't remember quite clearly. And I'm going to do a quick demonstration. This picture right here is me hiking up Mount Edgecombe, which is a really cool volcano. And this picture right here is my dog Pearl. She's a very good girl. And this picture is just a picture that I thought I looked good in.
Hello, my name is Vasu. Oh, okay, there. Hello, my name is Vasu Myers, a career graduate from Mount Edgecombe High School. Pilot Station, Alaska is my hometown, and that's what it looks like from above. It is located on the lower Yukon River of Alaska. That is me subsistence fishing during the summer with my family. That's of my family dog. She's a big puppy. Her name's Maya. That's me and my mother in Anchorage. It's cooler up there than it is down here. And that's me and my dad before my freshman year going to Mount Edgecombe. Thank you.
Hello, my name is Mars Crabtree, and I am from this place, Anchorage. It's the biggest city in Alaska. There's a little zoom in. It's right in this Cook Inlet, and actually the population of beluga whales has decreased over the decades. So kind of like a fun fact, but a really not fun fact. It's gone down from like, I believe about 1,000 to currently 290. So not doing too great in Cook Inlet. And this is a picture of me in marine biology, or not marine biology, it was AP biology. We had just finished stabbing a potato for a lab, and so I took a picture of it. I really enjoy science. And here's a picture of me at the Siga Sound Science Center, touching a sea star. And once again, I just really like science, and this is one of the reasons I decided to do Seatech this year. This is me in Sitka going on a hike. And this is me in front of the channel next to our school. And there's boats in the background. I just really love the ocean. And I also forgot to mention that I am a 4-year graduate of Mount Edgecombe High School. And Seatech has really given me the opportunity to learn more about the field I'm going to go into in college, and also figure out exactly if this is even something I'd like to do, which it is something I figured out I really like to do. So it's been a really good opportunity, and I'm very thankful. And that's all for me. Thank you.
Okay, hi, I'm Mary Simeon. I'm a 4-year graduate from Mount Edgecombe High School, and I'm from Bethel, Alaska, which is in the red dot right there. And this is me and my family right after graduation this year. And here's some of my senior photos that I took. And then this is me working at the hatchery at the Science Center this year. And then me and my friends from one of the programs I did. And I'm a 2nd-year intern, and I took Seatech because I'm interested in marine biology, and I felt like this program was really good at helping me decide which field I want to study in the future.
Hey Mary, can you go back to the beginning photo that you got there real quick?
This one? Oh,
Yeah, so this is the view from the Mount Edgecombe High School dorms. It's horrible.
Shmai, goeie Hallelujah, en laat ik me zo lang Mamaka Kilan Silvanga, Dadaka Nick Kilan Silvanga, Ilanka, and Alikmak. So I just introduced myself in my traditional language of Sistan. And I basically said my name is Nuhuya, but my borrowed name is Shania. My parents are Kilan and Nick, and we're from Nanwalik, which is the sector. And that's me, the summer with the helmet. That's my family right there, and then that's, oops. That's what Nanwalik, where Nanwalik is located. It's at the very tip of the Cook Inlet. And that's an aerial footage of it. Fun fact, we only have like 6-seater bush planes or boat to get in. We're not on, you can't access it by like a car. And so every time I go home in the winter, I get stuck and I'm late back getting to school. And then that's a picture of me and my dance group. We were the first ever Sukhiak dance group at Manachkam. And there was only 4 of us, the very first performance, and we gained 1 more. And I am a 2nd-year Seatech intern, and I wanted to join again because I liked it last year, and it's kind of helping me decide if marine biology is something I want to do. Thank you.
I'm Virginia Pearson and I'm from Sitka, Alaska. This is an aerial view of Sitka. And my house is like over here, so it's just out of the picture where I live. I spend a lot of time hiking, that's for seconds. I spend a lot of time hiking in these lovely mountains that we have in Sitka, and that's me getting stuck in the snow that was, I think about like that deep, maybe. And that's my dog, Hildegard. She's lovely. She's very short. I also really like to go to the beach. That's me with a purple shore crab. I really like crabs. I think they're greedy. I also dance with our local dance company. So that was from our gala that we did back in February this year. And I sing and play multiple instruments for our school music program, as well as for like various concerts in town. And I'm hoping to go to college for either marine biology or ecology after I graduate next year. And I am the last intern, so we're going to get into our presentations now.
Good afternoon, everyone. I'm Audrey, and in our group was Sarah and Virginia. And we studied the occurrence of anthropogenic noise, humpback whales in California in 2018. Our research was centered around the Megaterra novaangeli, or the humpback whale. The adult humpback whale grows between 11 and 17 years old, and they can be found in all major oceans. The humpback whale has seasonal migration, so in between spring and autumn, they travel up to 5,000 miles with warm feeding grounds and cold breeding and calving grounds. Their diet consists of small crustaceans like shrimp and krill, as well as fish. Here is what they sound like. And yeah. So in California, the humpback whale feeding, breeding, and migration grounds are close to the coast. So this brings them close to both passenger and shipping vessels, especially near large ports like San Diego, San Francisco, and Los Angeles. The image on the left shows the shipping traffic over a year long off the coast of California, with the warmer colors representing high shipping traffic and the cooler colors representing low shipping traffic. Sometimes when whales are calling in high shipping activity, it's hard for humans and other whales to hear these calls. This is called masking. So that brings us to our goal. We documented overlap between anthropogenic noise and humpback whale call occurrence. This is important because it determines shipping lanes and it protects humpback whales from human-caused threats. So the data that we analyzed came from NOAA's 2018 California Current Ecological Survey, which was abbreviated to CCES. This is a map of all of the 2018 CCES drifts, and this is a map of the drifts that we used in our research. We focused mainly on areas near large ports like Los Angeles, San Francisco, and San Diego. And the drifts that we analyzed were drift 10, 12, 13, 14, 16, and 20. And this gave us a large area covered by the hydrophones and a large amount of varied ecosystems. So the 2018 CCES data was collected using sound trap hydrophones on drifting buoys. And you can see in the diagram on screen that the acoustic recorder is suspended 100 meters below the ocean surface by the buoy. Using drift buoys has a few advantages. It's less expensive than dragging a hydrophone behind a boat for a survey, and they're not limited by depth like a stationary hydrophone would be. And they also allow for a larger area of data collection safely because they drift. But they do have a few drawbacks, one of which being that they can't record for as long as other stationary hydrophones can. They're limited by their hard drive and their battery capacity. So this data was duty cycled to combat this, which means that when this was duty cycled over 20 minutes. So when it was in the ocean, the hydrophone would record for 2 minutes and then would turn off for 18 minutes, and this would repeat over the course of the survey. Triton is a program that was developed here at the Scripps Institution of Oceanography at UC San Diego. And it's a custom MATLAB software that we use to analyze acoustic data. And Triton allows us to look at sound visually, both as a long-term spectral average or LTSA and as a spectrogram. And it makes it so that we don't have to actually listen to months and months of audio. We can scan easier. So this is what a long-term spectral average or LTSA actually looks like. So this is what we see when we're working. And it allows us to identify species without having to listen to all of the months of audio. The x-axis is the frequency in hertz, and the y-axis or plot length is time, and we have ours set to 1 hour. And the color scale shows the intensity of the sound with higher intensity being shown in warmer colors and lower intensity being shown in cooler colors. And if we want to look at something more closely, we can open it as a spectrogram, which allows us to both listen to and look at sounds in greater detail. Humpback whales generally call between 100 hertz and 3000 hertz, which we can actually listen to, and we will. Many ships also make sounds within this range of 100 hertz and 3000 hertz. We can see in the spectrogram, we can see these wave-like squiggles, which are our humpback whale sounds. And around 700 hertz, we see a ship passing through the same range. And this is actually what that sounds like. If I can find the person. Could you look at your button? Right on the screen. Oh, there. Right. Yeah. So being able to hear, sorry. So this is
This is important because the ocean is a very dark place and visual communication is often difficult. So having a lot of ship noise, having high amounts of ship noise in the same range as humpback whales are communicating in can make it difficult for the whales to hear each other and communicate, which is obviously not the best.
So I'll go ahead and get into our results. As a group total between all of the drifts, we made a total of 1,754 detections. These are the results from drift 10. Drift 10 is the northernmost drift we used and is located just off the coast of San Francisco. So overlap between ships and whales is expected. In this figure, it shows the drift presence detected along the map that the buoy took. It's a map, so on our x-axis we have longitude and our y-axis we have latitude. Right here, we have a color scale that shows the depth of water. The darker the blue, the deeper the water. In this figure, we can see that ships were detected throughout the entirety of the drift, and in these little white spaces is where ships were not detected. This figure is the same, but it shows when a whale were detected. So once again, we have x-axis is longitude, y-axis is latitude, and color scale is the same. We can see here that whales were detected more near shore than they were detected far shore. So this is a bar graph that shows the detections of ships and whales together. On our x-axis, we have the time of year, and the y-axis, we have the number of hours of detections. Between the two, you can see that there's some correlation as they make around the same amount of detections that are around the same time of year, right in these areas. This excludes August, however, where there is a high amount of ship detections with very low whale calls. These are the results from drift 12. Drift 12 is located just a little further off the coast than drift 10. We can see here that ship presence was detected throughout the entirety of the drift, while whales were detected not quite as much. This bar graph shows that throughout the entirety of the drift, there's ship calls, but whale detection is being made only every so often. These are results from drift 13. Drift 13 is located just off the coast of Santa Barbara. It only recorded for a couple of weeks, but we can see that when the ship noise is most present, the whale calls were not as active. There's a fair amount of overlap between the two right in this area. Drift 14 is just off the coast, right between Los Angeles and San Diego. As you can see, there were no humpbacks detected at all for drift 14. We only picked up ship noise. Drift 16 is located just off the coast of Mexico. It shows a high level of ship presence with very few whale calls. Although the drift only recorded data for about 2 weeks, it shows that there's slightly more ship noise before November 4th. And after November 4th, there are some blank spaces just around here where the whales do make some calls. This is drift 20, which recorded just off the coast of Baja California, and it is the southernmost drift that we used. It shows a fairly high level of ship activity, with also a relatively low amount of humpback whale presence. High levels of ship presence with corresponding low levels of humpback whale presence could be because whales are avoiding ships, although this is only in theory.
Our main goal of this project was to document any overlap between ship noise and humpback whale call occurrence off the coast of California. This figure is a compilation of all of the bar graphs from all of the drifts that we scanned, and it shows the overlap of ship noise and humpback whale sounds over between August and November of 2018. We noted an interesting absence of humpback whale calls in drifts 16 and 14, which were off the coast of Los Angeles. And this was vastly different from the other higher shipping traffic drifts that we saw, which were Drift 10 and Drift 13, which were off the coast of San Francisco and Santa Barbara respectively. The documentation of the location of humpback whales throughout their migration and throughout the year is greatly important for determining things like fishery closures and a placement of shipping lanes. Knowing where humpback whales are throughout the year can help us better understand them and better protect them.
So some other factors between anthropogenic noise in whales would be the difference between north and south, because there are more larger ports up north, so that would make more overlap. As well as, like I said earlier, whales migrate, so they may or may not be in this area during this time of year. The data we used was from August to November in 2018. During this time of year, humpbacks are more likely to be in Northern California than Southern California because of their migration route. Some future research we could go into would be reasons for drops in humpback whale sound, effects of the humpback whale migration from the ships, effects of masking on whale behavior, and how does that affect their communication? Thank you for your time. Are there any questions?
Did you notice any difference in the song that was being sung? Because in that area, you might expect that there would be whales coming from Costa Rica and there might be whales coming from Mexico. And I wonder if you just saw any differences in the song.
So we didn't really study the songs. We were just using every call to detect. So we didn't really look at the differences between them.
It might be something to put on your list for future.
Yeah.
questions. Now you know where they are.
Yeah.
I have two, really good talk, by the way.
Thank you.
Was the ship noise ever so intense that you may not have seen the humpback whale calls?
It was, there were quite a few areas of really high intense shipping noise, and yeah, we used a bandpass filter to somewhat block out lower frequency sounds that we don't see humpback whales making, but we did see some areas where even adjusting things like brightness or contrast and Triton, we couldn't determine if there were any humpback whale sounds.
Yes.
And then did you see any differences between overlap, like if there was more overlap or less between day and night?
We didn't see any.
No, we did not see any value variation. That was also something that we didn't really look at, so that could definitely be a really good future research question as well.
We could look at that. We didn't see any.
Super cool talk, guys. How do you recognize a ship in a spectrogram?
It's just a straight line. Like there's no like ups and downs, because it just makes the same noise continuously.
Thanks.
How much variability did you see in the different types of shipping noise?
Usually they have like around the same amount of hertz. Did you say between 500 and 700?
130. Yeah.
Between like 100 and 700 hertz, and that's usually the only type of variation. There's not really any changes in like how much they move or anything.
Thank you.
Thank you.
Please welcome our next presenter, Keisha.
Again, So my presentation is on the diurnal and nocturnal delphinic echolocation lake patterns off the California coast, and my data is from 2018. So the data was collected from drifting buoys off the California coast at 5 different areas shown in the picture. And the drifts were 10, 12, 13, 14, and 16. The y-axis shows the latitude and the x-axis shows the longitude. So in this table, it shows the start and end dates of the drifts. And this is important because some of the drifts, they overlap with each other. And we'll talk about that later. Okay, so the length of the species, the dolphin species, varies from 5 feet to 13 feet. Dolphins are also very social creatures. And the dolphins have a very similar diet consisting of cephalopods, crustaceans, shrimp, and small schools of fish. There is also a certain pattern that fish and other dolphin prey follow, and this is called the diel vertical migration. It is a behavior that some species of marine organisms exhibit, where they move vertically in the water, and it's shown in this picture, where they move to shallower depths during the night and then deeper depths during the day. They do this to avoid being seen by predators. And then next, I'm going to be talking about, I'm going to be showing some sounds of the species. So these species, they make a variety of sounds, and one of them is echolocation clicks, and they use these for navigating and foraging primarily. And then there's also buzzes and whistles, and they use these ones for social calls. But for my research, I will mainly be focusing on echolocation clicks, and I'm going to play some of the unidentified dolphin. Here is an echolocation clicks and the dolphin. For some whistles. And then next, we're going to be talking about the species that are in that area. So there's the common bottlenose dolphin and the short-beaked common dolphin and the long-beaked common dolphin. And next to them are pictures of their range maps of where they are located. And these are just a few of the species in the general area. And these two species, the Pacific white-sided dolphin and the reserve dolphin, have a very unique type of click where they have banding. And what banding is where the clicks have certain peaks that are shown in this image. This is of a reserve dolphin. And their peaks show up at 22, 25, 31, and 39. And then the Pacific white-sided is almost the same, but it has that different frequencies. And then some more information on these. And then my first objective was to explore the day and night variations for the dolphins between the drifts. And then my second one was to use the data to identify the different species of dolphins. So we'd want to know this because if their behavior changes, we want to know why this is happening and what's causing it. So how I got my data and the research that I used Triton, MATLAB and Triton, and in that I used an LTSA, which was explained earlier, and I only used an hour of data, and then I also used a spectrogram, which comes from the LTSA, and this is only a second of data, and it shown in the image are some clicks. And then I also used the time series, which is done right here, and I used the time series because this is another way of visualizing clicks. It's like a zoomed in way of looking at the sound pressure of a click. And in this time series, we're most likely seeing 2 clicks or just 1 click and its echo. So dolphin waveform clicks look different compared to beaked whale clicks. So right here is a dolphin waveform click, and then shown right here is a beaked whale. And the reason we use this is because we did not want to log a beaked whale as a dolphin. And so I labeled the beaked whales, Rizzos, and the rest of the dolphins were just unidentified odontocetes. Though I didn't get to log Pacific white-sided dolphins because we didn't find any in this area. So this is all the drifts compiled into one place and the locations. The x-axis is the longitude and the y-axis is the latitude. The pink lines show the unidentified dolphin echolocation clicks, and the orange, which you can barely see because it's only in one place right there, is the presence of a Rizzo. And there is very low presence, and it only shows up in drift 12. And there is no presence of Pacific white-sided dolphins. So this is all my data shown with the y-axis in months and the x-axis in hours throughout the day. The shaded areas show nighttime and the bright area shows the daytime. The blue lines, they represent the unidentified odontocetes, echolocation lakes. And we didn't put Rizzos or Pacific white-sided because there is such a low presence of both of them. And what I noticed by looking at these is that they mainly showed up at night. And this is like represented well in these two drifts. But in the other three drifts, there was more of a presence of echolocation lakes circled by the red lines that showed up during the day. And it was mainly around September, at the beginning of September. And this may be due to it being a different species of dolphins, or it could be evidence that the dolphins are feeding on different sources of prey that show up more during the day. So we were surprised to not see Pacific white-sided and Rizzo's dolphins in the data. However, my results are similar to findings from the past Seatech intern, Alexander Fisk, who was part of Seatech last year. So these maps show her results for Rizzo's on the left and Pacific white-sided on the right. She had looked at different drifts than I did, and she found a presence for both species, but is mainly in the northern drifts. And then both of the species were not depicted in any of the southern drifts, right there. So during that year, there's nothing that we know of that could have caused this change of the low presence. And I could imagine that some possibilities that could have caused this change could be changes in oceanographic conditions, human activity, and low food sources or natural disturbances. Though to find this out, we'd have to do more research. We know that there are a variety of threats that could impact these species, and we need to understand the distribution and behavior of these species in order to protect them. So some future research, one of the things was to check the effect of anthropogenic noise on dolphin communication. And then there's also to explore the role of social place or the social sounds and the different dolphin species. And thank you. Any questions?
I didn't get a chance to talk too much actually about your research, so I'm really impressive. And I just wanted to ask you, do you listen to these sounds more than any human being on Earth? Do you feel like the animals that are making sounds in the day and the night, are they making different sounds?
Like different sounds like location.
Yeah, like do you hear different characteristics or different sounds that the animals are making when you listen to them during the daytime when they're there versus when it's the night?
I didn't really notice any difference in that. Yeah.
So when you heard that these are little segments of 2 minutes of sound, right? That have been broken up. It's a duty cycle recording.
Yeah.
So when you detect the animals in one segment of 2 minutes, do you often find them in the next one? Or is it, once you see it in 2 minutes, it's not, you're not gonna hear it again for hours? I mean, the question is, are you counting the same group? You know, is it, when you detect it, there's a group and you won't count it again? Or the next duty cycle, are you counting the same group?
I would break them up into different, like when I'm logging them, I put it into separate. Like as a separate thing.
Was it often though that you'd see sequential detections?
Yes, because like I'd find some where it would be beaked whales and then it would be dolphins. It looked like it's the same thing, but it's not. You'd have to look into the time series to see. They were different species. Yes.
Great talk. Do the clicks always come in pairs to that species, or do they come in different groups of numbers of clicks?
Or like for dolphins, or like it's sometimes like an echo, or it's just like there's a ton of dolphins in that area at the same time. So
Oh, so it could be from different animals.
yeah.
Thanks.
Okay, thank you. Okay, next up is Mars and Johnson. Hello, it's me and Chelsea again, Mars and Chelsea. Today we are going to present on our findings. We're looking at the science of soundscapes and the species present in the Canadian Arctic during the years 2017, 2019, and 2020. Our objectives were to log and identify different marine sounds, such as marine mammals, environmental sounds like wind or anthropogenic sounds, mostly ship noises. We also wanted to create a sound file that was able to convey the different sounds in a concentrated area, in our case, Pond Inlet. We also wanted to investigate relationships between the environment and the presence of marine mammals.
So the materials that we used were from the Scripps Institutional Whale Acoustics Lab provided by HARP data for us to use in our research. The hydrophone deployment was in Pond Inlet for both of our deployments. The years we studied were spring and summer of 2017 and fall of 2019-2020. The deployments were in separate locations, which we'll get into once we break off into our separate projects. And to look at this data, we use a Triton program on MATLAB for creating the actual sounds script we use for an audio program called Audacity.
So the data that was collected, that we studied, was collected using a HARP or a high frequency recording package. And this is very different from a drift. This is stationary. So the Scripps Institution Whale Acoustics Lab provided the HARP data for us to use in our research. The standard height is about 10 meters long, although in different deployments, the shape or the general how it looks or how long it is can vary. And if we look here at the top, we have the flotation devices that keeps it 10 meters above the seafloor. And in the middle, we have one of the most important parts is the hydrophone, which is what's actually picking up and collecting sounds. And that's why we call it the ears. This is the ears of the HARP. And next we have what we call the brain, because this is where the data is stored during the deployment, and it also contains other important things like weights that keep it down. So then the flotation devices at the top don't just bring it right back up to the surface. And these weights also get released once the deployment is over, and all of the data will be able to float to the top. And they also have batteries to make sure the device stays charged. the methods we were using. Well, we scanned data in Triton, so this is what our screens were looking like. We've already had a little rundown of using Triton, so LPSA, and this is, I took this sound down here from right here, and this is a narwhal buzz, and I used a bandpass filter to cut out all of the extra sounds. And we also use time series to look at amplitude to identify exactly what kind of social sound it was. We also used Audacity, as mentioned before, and this was just to amplify sounds and add different effects when I was making my soundscape. So we put the sounds in here, and you were able to fade in or fade out and layer different sounds together.
I listened to data from the pond inlet deployment at the start of spring, which was March, and ended in early July or June of 2017. And here's a closer look at the deployment, which is right around here. I listened to a lot of bearded seals or Ericnathus barbatus, and in my language, which is Siberian Yupik, we call them mukluks. They're very delicious. And here, they live in the Arctic or subarctic. And here's a picture of my 6-foot brother laying next to a bearded seal. And now I'll play a recording of the different type of bearded seal calls. I also listened to a lot of ring seals in Pond Inlet. They are also very delicious. And they are also the common seals in the subarctic and Arctic. And they are the small seals because they have a small head and a cat-like snout. And their claws, right here, are about 1 inch long and super thick. The reason why they're so long is because they use their claws to make breathing holes during the winter. And here's what they sound like when they make their breathing holes. Here's a picture of my brother Orland, who took this class. He had just got this ring seal, and it's a fishing pole, but normally we use these hooks to get the seal off of the water and on land, and we also use them for when we go bird hunting for the same purposes. And this picture is a picture of the spectrogram that shows the bearded seal trills and calls, along with one ring seal bark. And very faintly are these narwhal quicks, which I only heard like a couple of times, so I didn't really log any. And now I'll be playing a video of me interviewing my dad for my scientific research.
Do you see ring seals and bearded seals at a different time of year, or are they in the same time of year, like season-wise?
Ring seals and spotted seals?
Yeah.
You usually see them in the year-round, more in the spring.
Right, what about bearded seals?
Bearded seals are migratory, so you see them late in the fall when the ice starts forming, or spring when they're having pups.
Right. Are there different, is there a different species in Nome than like St. Lawrence Island or Pond Inlet, or are they all the same?
They're pretty much all the same. The only thing is their diet is different.
Like what's the diet in Savunga?
The Savunga, where I'm originally from, the meat is more fishy, And then in the mainland in Nome, they're more like tundra, grass smell. You can really smell the difference when you're cooking them and plus tasting them.
Thank you.
Now, this picture shows one of the very many steps that we use. So in this picture, it shows how we stretch out the fur for when we make our traditional clothing. This picture right here shows my mom wearing her utkuk, which is a traditional jacket. And back on the back is spotted seal, and in the front is ring seal, along with other furs. And in this picture shows a picture of my relatives wearing dimkoks, which is the word for traditional pants for when we used to go out hunting. Along with these boots right here, which in our language we call them gamoks. And they're both ring seal and bearded seals. And this pie chart shows the occurrence of each species I detected at the pond inlet site. Most of the calls I detected were bearded seals, and followed by ring seals and some other identified marine mammals and anthropogenic sounds. Now, I challenge you to hold your breath as long as you could for this bearded seal, the longest bearded seal show that I detected. All right, raise your hand if you did it, if you made it. Congratulations, now all the female bearded seals would like to mate with you. The trills are from the male bearded seals, those are mating trills. And while you recover, now we're gonna listen to one of the combined audios of ring seals. The importance of this chart shows the seasonality of when these animals are present and how frequently they make their calls. In the previous chart shown, it showed the data that I analyzed in the springtime of Pond Inlet that also had the same types of mammals that we encounter in the springtime of my hometown. And this data shows both my family and the Inuit people why we hunt these mammals in the spring. And with this acoustic data, it helped me understand the importance of the circumpolar species of all the people that live around them. Even though the distance from Nome, Alaska to Pond Inlet, Canada is over 2,000 miles apart, it is just as important to know everything that we can about the species we subsist upon.
The data I studied was in Pond Inlet, still right up in Baffin Bay. This was deployment 5, which is 2019 and 2020. And here's a little zoom in on, here it is, it's right at the entrance of the inlet. And I set, the dates of mine were in the fall of 2019 and the fall of 2020. I will now go over some of the marine mammals and sounds I heard in my data. So I heard lots of narwhal sounds. They have a pretty restricted habitat up in the Arctic. And here is what a narwhal. So that was a narwhal buzz. And you'll hear more about narwhals later on from Mary, but they're a lot bigger than I thought they were. I don't know, I just imagine narwhals a lot smaller, but they are relatively small compared to other odontocetes. The next one I heard was killer whale. This is the second smallest species that I heard in the data I studied, and they pretty much just follow their food source around the waters, so they can kind of be found anywhere. And they have typically less than 40 whales in their pods, and they're pretty noticeable with their black dorsal fin and their black and white patterns. I also heard sperm whales, and these are pretty much anywhere neighboring to the ocean, and they typically don't actually go that far up north, which is why there was in the data set I studied, there was actually a lot less sperm whale sounds. And here is an example of sperm whale sounds specifically. This is coming from a male, and it's what we classify as a claim. And yeah, they are also huge and they're really loud. So the last marine mammal was the biggest, it was the bowhead whale. And they are just like the narwhals, they have a pretty restricted habitat up here in the Arctic. And I will now play one of the songs I found. So that was a bowhead whale. And then other important sounds you want to listen for in the Canadian Arctic are anthropogenic sounds, because right there in Pond Inlet there is a shipping lane, and these are going to affect these marine mammals in so many different ways. And then you also want to pay attention to the environmental sounds, and I'll actually play a sound from a ship. I don't think I'm going to play the whole thing because it's like a minute long, but this is what an encouragement. So anthropogenic ship noises like that can be categorized. They're really loud and they kind of have that buzz to them, or like kind of like a humming sound. And then the next one is an environmental sound, and I want you to take a look at this spectrogram, and you see all this, and then I'm gonna play you the sound, and I want each of you to take a guess as to what it is. So be prepared for some interesting sounds. Okay, before I tell you what that is, in your minds, just make a guess as to what you think that is. And I will let you now know that that was the formation of ice. It was ice scraping together, and I want a raise of hands to see if you got that right. Yeah, to me, when I first heard it, I had no clue what it was, and it kind of just sounded like a bunch of whales being tortured, which was pretty terrifying. And so these are the results of Pond Inlet Deployment 5, this one that I listened to. And this took place from late September to November in 2019. Now this is a pretty interesting graph to look at. First, we have this dark faded area, and this was the time where it was night, and then the light part right here in the middle is the daytime. And so at the beginning in September and October, we have these anthropogenic sounds, which are highlighted by the blue. That, let me explain, the x-axis is the hours of the day, and then the y-axis is the time of year. So we have like a bunch of narwhals, especially right here in this middle part, and that is the code for that is MM. And then later on, we also see these bowhead whales in November, which is the like dark green color. And then we get this ice formation starting right in mid-November. And then we have a lot of environmental sounds, which, as you can notice, like the ship sounds stop right around when the ice starts forming, and so do the normal sounds. Narwhals can't really break through ice that well, so they will stay out of the ice area. And same with ships, their shipping kind of stops around this time. And what we do notice is that there's a lot more environmental sounds that can be heard. This is like wind, storm sounds, wave action, and this could be for multiple reasons. Like we're hearing less other sounds, or that the ice is amplifying these sounds and making it easier to hear. And then one thing that was really interesting is down here, there's a little bit of bowhead whale, like after a bunch of ice has already formed in late November. And this could be because they follow the ice for their food source, such as like small crustaceans like krill that gather along the edges of the ice. This is my technograph. This was a much smaller disc. This was DIP 6, and this took place from late July to August of the year 2020. And this one is less exciting, I will say. There's this tiny portion because there was continuous daylight right here until late August when they finally started to have some nighttime. This is the one that was really interesting because this yellow right here, and you can see above August 2020, is actually sperm whale. And as I mentioned earlier, it's a bit odd to have sperm whale this far north. The usual anthropogenic sounds, and then a little bit of orca action up here. Now, this is the soundscape I created. Before I play it, I would like to say that we are currently considering some of my sounds to be added to this website that is used for locals in the pond inlet area. They find these sounds very helpful to understand the soundscapes, and I will talk later after I finish playing the soundscape, the importance of soundscapes and why I took on this project. So, this follows my data, or the data I studied. It follows the whole year. So that was my data, the data I studied pretty much all in one sound clip. You heard lots of different sounds, and that just shows how noisy the ocean actually is, because for a long time we thought it wasn't that noisy. And this is just to go over the graphic once more. I found all these 4 marine mammals. I didn't find any ringed or bearded seals like Jelly did, but I definitely found lots of anthropogenic noises. And one main point of my discussion is going to be sperm whales and why they were that far up north, because they are usually a mid-range creature. And so I took this graph from a research paper I found that shows sea ice and its relationship with sperm whale presence. So sperm whale presence is this teal colored bar graph, and the sea ice is this light blue line. And it pretty much just shows that when the sea ice isn't there, the sperm whales will be there, and most of the sperm whales detected are going to be male sperm whales, since they're the ones between male and female sperm whales that are going to do the exploring. And that is true to the data I studied, because the claims are specific to male sperm whales. Other important things to discuss are the importance of soundscapes. So we're trying to figure out how all of these things are playing together in the ocean, how they are all affecting each other. And it's important for us to make soundscapes like these to show other people like how to understand the ocean better. I mean, once again, for a long time, we thought the ocean was just chilling, nothing going on really, but now we know a lot better, especially as anthropogenic sounds increase. It's really important to understand the impact of these noises on marine life. So using several different soundscapes in the future, we may be able to better track migratory patterns of animals and their behaviors. And here's some perspective research questions that I came up with. These are just a few, definitely not limited to just these. So where are marine mammals migrating? Because we don't know the full scope of that. It's very hard to track them. Why are they migrating? We also don't know a lot about that. And then what observable changes are seen in the data over time. So we listened to Pond Inlet in 2019, 2020, but like, what about in 5 years from now? What is it going to sound like there? Because as sea ice decreases, like the amount of time sea ice is there decreases as climate change goes on, we might see a lot difference in anthropogenic noise. So it's going to be really interesting to observe how the data will change over time. And thank you, and we'll take questions now.
That was really great. I'm wondering if the sound is restricted to just the inlet, or if it's from far away, or how far away that sound might be coming from. Do you know?
I'm actually not 100% sure how far the hydrophone records, so I think it's mostly restricted to just right there in the inlet, really.
Why did you guys study out of the 2018?
So actually, like when we first got this class, like first trimester, there was a group of 3 of us, but then the person who had the 2018 data, he had that data. So when he dropped the class, he wasn't able to help us provide any more information.
Any other questions?
Just this question to you in the chat. Can I read it to you? Okay. It is from Lisa Ruki Rarick. I like how you connected your family's experience with bearded and ringed seals with your research on the vocalizations of pinnipeds. From your graph, most of the vocalizations you heard were of bearded seals, which tend to be farther offshore than ringed seals in the spring. Were the recordings made in more open water / pack ice environments in the spring? I missed the time of year when you were analyzing the calls and was wondering if ringed seals would be more likely to be in fast ice closer to the shore during the pupping season, and that might be a reason why you mostly heard bearded seals.
So I think, so with my family, when we go out hunting and stuff, we normally get seals when the ice is either getting like breaking up into, there's like big chunks, or in just like sometimes when there's like no ice, which is when we get a bunch of ring seals. And so I'm not really sure why I didn't hear any more ring seals. So
With the program you found later in November, did you notice that there was a different frequency or different type of calls in the early ones?
No, that I noticed, there was no difference between the sounds. Is that all?
It's not a question, but more of a comment. Mars, I really appreciate that you made your own soundscape, and we've been delving into that in my lab. But to actually see someone put their own soundscape together, and at first to me it sounded like the rainforest, and it's really cool to see those parallels between terrestrial soundscapes and ocean soundscapes. So good job.
I think that's all. Thank you, and we'll be welcoming the next presenters, possibly, and Harvey.
I am Harley.
And I'm Vosley. And our research project is on neural social balance in the eclipse zone region of the Canadian Arctic from 2019 to 2020. One of our objectives for this project was to detect and log neural social sounds. We were looking for neural burst pulse sounds. Under 10 kilohertz is where social sounds frequently occur. Low frequency neural sounds are known as social sounds and are employed in a social setting. Our next objective is to showcase these sounds and identify the different types of sounds.
Narwhals or Monodon monoceros are part of the Odontocete suborder, and this map shows where the narwhals reside. Narwhals are on the smaller side of Odontocetes, and they are pretty close in size to beluga, and they live a predatory lifestyle on different types of marine animals such as halibuts, cod, shrimp, and squid. And in Inuit folklore, the story in which narwhals originates starts with a blind man and his stepmother. The stepmother mistreats him during his time as a blind man, and the blind man regains his eyesight and takes his mother out to the water, where he lashes her to a white whale. And the stepmother has her hair twisted in a way that resembles a narwhal tusk. And as the whales she is tied to go into the water, she drowns. And after the woman drowns, the man sees that a narwhal has come back in her place because he regained his sight. And I shared this story because narwhals are very important to Inuit people, and they are hunted and relied on for subsistence and indigenous lifestyle.
The hydrophone that was set in the eclipse sound region of the Canadian Arctic provided the data that we go through. On the map, the red dot indicates the deployment of Milne Inlet of the northeastern Canadian Arctic. Narwhals often pass through here, so we gather tons of narwhal acoustic data that we use for analysis. This is significant because it is a crucial swimming ground for them. Harley scanned through early fall of 2019 of Milne Inlet in the Canadian Arctic, while I scanned through the summer of 2020 of the same project. Data from mid-September through mid-November of 2019 make up Harley's data, while my data covers a period from early July to mid-August in 2020. We used MATLAB and Triton with the Arctic logger remora that created a detection with Microsoft Excel. The reason there's a gap between the two dates is that there is little to no normal activity during these times due to ice coverage being most likely present. And during that time period, we didn't search for any calls.
So we use Triton, and our methods for finding narwhal social sounds was to find timeframes in the LTSA at a high frequency for narwhal clicks. And once we found those clicks, we find the beginning and ending of those clicks. And at those times, we scan in the spectrogram at a much lower frequency. So in the LTSA, we went from 0 to 100 kilohertz, while in the spectrogram, we went from 0 to 10 kilohertz. And that's how we found our narwhal social sounds. And here is a faint example of narwhal social sound. And here is our showcase of different narwhal social sounds that we found. So this one kind of just looks like red blotches on the spectrogram. It's a very loud and clear example of a verse pulse sound and what we mainly thought of when we think of narwhal social sounds. This one looks a little bit different in the spectrogram. As you can see, it has a little bit of an upsweep, and it was a lot less common than the first example. This one is a little bit closer to a whistle and is also fairly common. And this one is pretty similar to the first one, and the sounds are a bit faster and they're closer together. And this one is pretty similar to the first and fourth one, but it goes on the longest and is just a good example of a little bit longer period of narwhal burst pulse. And these are the plots that I logged. The y-axis is the month or like the day of the month in September. And the x-axis is the time in hours like of the day. And I scanned through a bunch of different types of noises and sounds, such as anthropogenic sounds. There was ice, as you can see right here. That was the only example of ice that I found. And there was also killer whales as indicated by OO in the green. OO is just Orcinus orca, which is the scientific name of killer whale. And there's also just other unidentified sounds, and UMM is unidentified marine mammals, so I could tell that they were marine mammals, but I couldn't tell what they were. But most importantly, I found a lot of narwhals like in my scannings, and MM is Monodon monoceros, which is the scientific name of narwhals. And they would come in pretty long periods of time because narwhal clicks usually lasted pretty long. And this graph just shows that there were many kinds of sounds around the Milne Inlet area, and it was not exclusively narwhals. And this could show that there are some other factors to determine when narwhals make different types of social sounds.
This plot is like the one in Harley's Blight previously. The x-axis and the y-axis are the same, except the colors and dates differ, as you can see. My loggings were mostly focused on the narwhals represented by the encircled green lines and labeled as MM, which is short for Monodon monoceros. The light bluish color is ice, while the dark bluish colors are anthropogenic or man-made sounds. These are light blue and dark blue. Noise is icky, but sound is great. Orcas or killer whales are indicated by the brownish lines and OO, meaning Orcinus orca. Because there was a lot of sea ice present in the beginning of July, there aren't many narwhal social sounds recorded. Also, it was a slow process, so it doesn't show the rest of the time period through August. We did compile narwhal social sounds. We did find different kinds of narwhal social sounds. We think that the reason for such a variety of social sounds is that narwhals use different sounds in different situations.
And the reason that we focused on narwhals is because there isn't very much research on their social sounds below 10 kilohertz, because most of the research done and acoustic data done on narwhals is on their higher frequency clicks. And narwhals are also extremely important for Inuit people in the Arctic, in Canada and Greenland, because they do hunt narwhals and rely on them for subsistence. And we think that gathering acoustic data could be helpful for protecting the narwhals and way of life of Inuit people against any harmful factors such as like environmental change, which could affect sea ice and ship traffic, because there is also a mine near Milne Inlet which causes ships to pass by a lot. And a possible future research project for narwhals is to compare earlier years of narwhal presence to modern presence to see how they have changed because of those previously mentioned factors. And another possible research project would be just to go further in depth into narwhal classifications for their social sounds and just learning why they make the different social sounds. And thank you. We are open to questions. Yes.
Get to look at any period or any period of times where the narwhals are echolocating but not local sounds.
We did not, because we were just looking for areas where we knew that narwhals were, and it was just very simple to look through their periods of clicks. But we think that it could also be cool if someone looked at periods where there were no clicks and see if there are also social sounds in those areas. Now we welcome the next person, Shania.
This year, my presentation was on the seasonal presence of baleen whales in Natsiavu, Canada in 2021. My study site was off the coast of the Torngat National Park in Saginaw Bay, circled there. The other triangle is another harp site. And my data was recording from August 10, 2021 to November 15, 2021. The objective of my presentation was kind of really to see if there's anything or any baleen whales in this area. And to see, basically to see if anything was there and what is there. And my overall objective was to help the United States territorial government make a conservation site in this area, which is off the Taronga National Park. And they're wanting to make it a conservation site, not just to protect the biodiversity, but also to protect the Inuit culture and traditions of the people who have been there since time immemorial. And they were able to use harps to help with this data. I also use MATLAB and Triton and the LKSA inspectogram, but mine was a little different. But I listened to a lot lower. My plot length was shorter, and when listening to sounds, specifically baleen whales, you need to speed up your time by 5 times to hear them, because regular human ears can't hear that. And I use the Arctic logger method, which is this picture, and we used the signal types to log it. Instead of basically saying this is the whale we think it is, we log it by the character style and frequency of the call we found. And together, me and my mentor, Kayla Haas, logged 801 encounters in the 4 months of data. This is to show the different species we think we found. So minke whale, sei whale, bowhead whale, North Atlantic right whale, and fin whale. And now we'll go into why we think we found these species. The first signal type I found was a pulse chain signal type, which to classify a pulse chain is, first of all, a pulse is a call that's really short and it doesn't really have that long of a duration. And so a pulse chain is a set of pulses that go on for a certain amount of time. And that's what this picture is right here. And I'll play that sound for you before we go into the graph. And the graph in the picture right here is to show when in the day they were calling, which is the x-axis, and when in the day we found them, which is the y-axis. And as you can see, they're highlighted in blue right here. Most of my encounters were found in September, with an exception of one in August and one in early October, and nothing in November. And we would classify a pulse train to be matched with a minke whale. So when we come across a pulse train, we would think that there's a minke whale in this area, or that was something that I encountered. My next signal types are the downsweep signal type ranges. To classify a downsweep, it is by the start frequency is higher than the end frequency, and to class, hold on. And there's different ranges of frequencies. So from 90 to 14 hertz is kind of the range, and the range depends on what species is making that call. And so the different range, the first range I have is a 90 to 30 hertz, which is in the spectrogram here, and I'll play that sound for you. For some of the downsweeps, you do have to speed up the sound, but for this downsweep range in particular, you didn't have to because it started at a higher range. And we would typically match this range with a sei whale. And my next range is 30 to 14 downsweep, which is in that square here, and I'll put this. this is one of the sounds that is needed to be sped up. And we would typically match it with a fin wheel. And my last down sweep range is a 50 to 30 hertz down sweep. And I'll this sound also had to be sped up, and we would match it with fin or sea whale. And I kind of made a connection from my last year's project where I had found fin whales last year, and I read that they usually call at 40 or 20 hertz, and that is kind of in between the range of a 30 to 14 and a 50 to 30. So I use a lot of literature and thorough reading to help me identify the signal types and what species would typically be found with which one. And here's my graph. The X and Y axis are the same. These lines here are to kind of solve the first plot and go into the next one. So this plot is a down sweep 90 to 30. This one is a 50 to 30, and this one is the 30 to 14. And as you can see, there is we found a lot of down sweeps, and they're pretty active through the whole time, except for really November. And we found more 40, 50 and 30 and 30 and 14 than 90 to 30. My next signal type is a upsweep signal type, which we would match with a North Atlantic right whale or a bowhead. I'll play. An upsweep isn't a signal type that you need to speed up to hear, but it also is kind of the opposite of a downsweep. So the starting frequency is lower than the ending frequency, and that's how we classify it in upsweep. And in my graph, the X and Y axis are the same, but you can really tell there wasn't a lot, and they kind of be found anywhere, and it was really scattered to when they were present, with nothing happening in October or November or no detections made. And my last and actually favorite signal type I found is a banded signal type, which you typically match with a bowhead. To see the shape of a banded is in this square here. And to classify a banded, we look at the shape. So this last call is actually the first call that a whale would make, and these top ones are itself harmonizing with that call. And so that's how we figured out what a banded was. And my plot is the same, except to show banded in the blue. And you can see there's nothing really found. And there was 3 that were pretty close together in the same month, and there was one pretty long one found in October. Other than that, nothing else was found, and with the exception of nothing found in November. And when I was getting my sounds just yesterday, we figured out that the banded happened before the upsweep, but they were close together. So the upsweep and banded I have shown is most likely a bowhead doing 2 different signal types. I didn't mean to click. Okay. For my discussion, We were looking at many reasons to why we were finding these animals during this time or why we weren't. And one of ours was migration. Using different kinds of literature, I found that all the whales that I found are typical to be found in this area due to migration and coming up for feeding areas. And we also were, if you didn't notice or if you did, there was no detection made in November by any of the species. And we didn't find any signal types found in November. And so I was interested in that. So I went and looked at the seasonal, if there's any reasons, and we found a seasonal environmental reason, which would probably be ice. From late October into November is kind of when ice starts to form. And so that is one of the reasons we think there wasn't any whales found during this time, since bathing whales typically feed off the surface, and it would be hard to feed in icy areas. Another point that I wanted to make was a species richness. I originally thought that I wasn't going to find anything. I didn't know if there was going to be anything here because of the ice coverage, or if it was just hard for bathing whales to go feed up there. But as you can see, I found 5 different types of species, which interestingly, a few of them are endangered. And so that was really cool to me. And I also found a pattern in the down sweeps. So originally I had each down sweep on a different slide, but later on I found that every down sweep is the same. It just depends on the species that is making the call that makes it a different style or range for the down sweeps. Some of my partners or people that helped me make this project were my mentor, Kayla Haas, Scripps Institution of Oceanography, UNACIA Government, and Oceans Net. Guyana, thank you. Any questions?
Do you have reason to believe there's any other types of species up there?
There was a few calls that I thought that could be something else, but there wasn't enough. But I'm not really sure, which is something I would want to look into more thorough and a longer data year.
I don't know too much about this. This is all very impressive.
Mhm.
But I was just wondering if you were able to tell the difference between whales of the same species that are at different maturity levels, if they make different calls.
I didn't look at that, so I'm not sure.
Wait, what about blue whales?
Um,
I would expect they'd be there, but, you know.
So actually, when we came down to San Diego, I had like 16 slides. I thought I found a blue whale, and which would be like an 18 hertz call, and that's what I thought I found. But when we zoomed into it, it wasn't 18 hertz. So I wasn't really sure, and I wanted to kind of look into that. But when we figured it out, I didn't have enough time to.
Yeah, the problem is they're just these kind of long phones, so.
Yeah. Now I'm very nearly our last presenter.
Hi, I'm Mary Simeon. This is my presentation on possible impacts of killer whale presence and anthropogenic noise on narwhals in the Eastern Canadian Arctic in 2019. Okay, that was a really fast zoom in of where my location is, but this is a better photo of it. I had 2 sites that I worked with, which were Low Island and Pond Inlet, and I will be referring to them as Low Island and PI. Both the sites are located in Eclipse Sound, and another thing to note is that there is Mary River Mine, which is in the little bright purple circle at the bottom, which has increased the amount of shipping traffic within the area. And the first species I worked with was the narwhal or Monodon monoceros. It has a tusk that comes out of the top of its head, and it has a brownish or grayish body that turns darker as they age. And their main prey are small fish, shrimp, and squid, and their main predators are humans and killer whales. And they can get up to 11 to 16 feet and weigh up to 3,500 pounds. And the purple circle up there is where my site was. This is the killer whale or Arsenis orca. Their main body characteristics is that they have some counter shading at the bottom of them, so that means that they have a white belly and black body, and they also have a big dorsal fin that comes out of the top of them. Their main prey is marine mammals, and they can get up to 18 to 32 feet and weigh up to 22,000 pounds. And the purple circle again shows where my location was. That's the killer whale. My three main objectives were to identify the acoustic presence of killer whales in Eclipse Sound and do narwhal echolocation fix stop once killer whales are present, and do narwhal echolocation fix and once anthropogenic noise is present. These are what my species sound like. And this is what the narwhal sounds like. This is what anthropogenic noise looks like, and one thing to note is that instead of a 2-hour call length, which was my regular time, it is set to 6 hours because I wanted to show the length of the anthropogenic noise, and it goes for about 4 hours. And this is a small ship which may be able to mask the sounds of other marine mammals such as the narwhal. And here are my materials and methods. I use Triton, which is a program on MATLAB, and then I also use the Arctic logger, which is a little different from the regular logger because it has marine mammals such as the narwhal. And I logged every single narwhal echolocation click, killer whale social sound, and anthropogenic noise that I found. And my two sites I looked at were the line and pond inlet, and this is the timeline of it at the bottom, and they overlap in time. And pond inlet starts mid-July and ends early September, and Low Island starts in late June and ends mid-August. And here are my first results. As you can see on the x-axis, it's time in hours, and the y-axis is the months. And the dark blue is the anthropogenic noise, and the lighted blue is the narwhal, and the light green down here and up there are both killer whale, and the bright orange over here are unidentified marine mammals. There are some narwhals in the earlier months, such as July, and the later month, August. And there are some killer whales in the data in July and also August. And then this is my other site, PI, and the X and Y axis are the same. The only thing that's different is that the killer whale is a different color, and the color is orange this time. And in the beginning of the data, that there's narwhals appear in early July and narwhals mid-August, and there's anthropogenic noise that starts mid-July, and there's also some killer whale down there, which sorry. And yeah, this is my conclusion. One observation that I made while looking through my data was that one example that I found was that in here, there's a lot of kind of normal echolocation clicks, which you can tell there's a lot because of the dark red. And that right here, after about an hour, the normal echolocation clicks stop. And once I looked through the data, I found that there were killer whale, signs of killer whale, which was a good indicator that killer whale might have caused the normal behavior to change. And on the anthropogenic side, you can see that the normal picks are right here, and then once the ship is getting closer, the normal picks stop, and they come back after a little while. And this is my discussion. Killer whales have been shown to have a presence in both my sites, PI and LI, in Eclipse Sound, and that both anthropogenic and killer whale seem to impact normal behavior, but further studies are recommended. Two future study questions that I have are, is the presence of killer whale increasing in Eclipse Sound due to climate change? And to further study, and future studies are needed to understand how narwhals are being impacted by anthropogenic and killer whale presence. And thank you. Are there any questions?
Really nice talk. Did you see any instances where there were lots of clicks? So there were narwhals there, and then also were there any other vocalizations that went along with that that made you think they would be attributed to the narwhals? But just because the narwhals are there, like the social sounds that we talked about earlier.
The social sounds? Yeah, so I do mean like normal social sounds in the clicks, like present in the clicks, or like other social sounds.
You know a lot more about this than I do. So I think what I'm at like this is something other than a click there that you can say, because it coincides with the clicks, it must be narwhals.
Yeah, last year I worked a lot with narwhals, so I have a pretty good understanding of what like narwhal clicks look like and their social sound. So it is pretty easy for me to identify whether it's a narwhal.
Cool, thank you.
Yeah.
So last year in the meeting with the Economic Hunters and Trappers Organization Board, which is the Wildlife Management Board in community of Ponding, it gives us permission to do this work. One of the board members asked a question: do you hear a difference in the way that the narwhals make sounds when there are ships around versus when there are killer whales? And they weren't asking me to show them a plot or to write a paper about it, but to answer. And I balked because I didn't feel like I could answer. But I would ask you to listen to more than anybody else. Same question. Do you feel like there's any difference in sounds animals make with ships versus killer whales?
Yeah, from my observations, I have seen from the example that I showed earlier that they stop, and like from this example, when I was looking through it, after the killer whales were present, I didn't hear any narwhals anytime after that, and the anthropogenic, they would like sometimes pop back up, but like not as much. So. Any questions? Yeah.
I guess I have a follow-on question to that. Do you think that the reason why the sounds go away is that they've left the area entirely when there's a killer whale, or have they just stopped making vocalizations?
I would assume, sorry, but for future research questions, that's a really good idea. But from my observations, we can't like physically see the narwhal or anything, but they come back after a little while, so I think that they just like get quiet because they don't want to be eaten or anything, so. And for their acknowledgements, I couldn't have done this presentation without the support of Susan Connie from Manchcom High School, Noah, Shannon Rankin, the Southwest Fisheries, Saltwater Inc., Dr. Hildebrand with the Whale Acoustic Flag, Scripps Ocean, Scripps Institution of Oceanography, the Mixed-Matholic Hunters and Trappers Organization, Oceans North, and the mentors, Aaron Deans, Ann Samoas, Eric Snyder, Ava Hildego Pla, Harris. I'm gonna mess this up. Papa Trejas, Jack Ewing, Josh Jones, Kayla US, sorry. Kristen Westall and Morgan Zigenhorn. Yeah.
I have just one, thank you, I just have one more question.
Yes.
This question comes from Jonathan Fitziola, who's current member of the Mixed-Matholic Hunters and Trappers Organization, who's listening here. And he asked one more question, and that is, do you have an idea of the distance from the narwhals to the ships and the distance to between the narwhals and the killer whales when the narwhals react to each?
I haven't looked at that in my study, but that'd be a really cool research question in the future. Yeah.
What are Navy SEALs?
It's a good question, but I don't have that slide in here. Yeah. Yeah.
So we have some gifts for our patrons. So one more round of applause. Great job. This is the easiest job in the world, man. They make me look really good. So for those of you that are here or watching online, please hire these young people. They want jobs, they want to work, they want to make a lot of money, and they love the ocean. So they'll be great employees. It's a very cultural tradition in Mount Edgecombe in Alaska to do gift giving. So we have some, you cannot leave Mount Edgecombe High School without a t-shirt. So we have some t-shirts for our mentors and some Theobroma chocolate that's made in Sitka. And all of you. There you go. Okay, so yeah, Sarah is not the only person who had a mentor. So let's just kind of spread that out and bring the mentors up. And yeah, I just want to say thank you for all of you who came online, and thank you for those of you who came in person.